In this video, we are going to attempt the structured questions which are related to atoms and electrons. So first of all, a neutral atom of an unknown element contains 35 protons, 45 neutrons and 35 electrons. Identify the element. So if we write it like if it is going to be element, let's consider it as X. And we know atomic number represents the number of protons, so that is going to be 35. And atomic mass is basically the sum of neutrons plus protons, and that comes out to be 35 plus 45, that comes out to be 80. And this element basically represents bromine. Define the mass number of an element, and the mass number of element represents the number of protons and the number of neutrons. So mass number represents the number of protons plus neutrons, and the mass number of this element is going to be 80, because that represents the number of neutrons and protons. If the atom forms a -1 ion, describe what happens to its electron count. So what happens to the electron count? Because if it is -1 ion, then it represents that atom has gained 1 electron. So what happens to the electron count? That means it increases by 1. Explain why the nucleus remains unaffected when an atom gains or lose electron. Because the nucleus contains the number of protons. Nucleus contains protons and neutrons, which are not affected if there is increase or decrease in electron. So in this question, they are saying define ionization energy and explain what it measures. So ionization energy is the minimum amount of energy required to remove electron from a gaseous atom, to form 1 mole of gaseous ion. You can see we have sodium. It should be in gaseous form, and when an electron is removed from it, it is going to form 1 mole of gaseous ion and 1 mole of electron has been formed from it. Use Coulomb's law to explain why chlorine has higher first ionization energy than sodium. First of all, Coulomb's law is F is equal to K Q1 Q2 divided by R square. And we know sodium is having 11 atomic number, which is the number of protons as well, and chlorine is having 17 as the proton number. So what happens? Chlorine would be having the higher first ionization energy. Why? Because chlorine has higher first ionization energy. What is the reason? Ionization energy. What is the reason? Because chlorine has higher effective nuclear charge because chlorine has higher effective nuclear charge. Got it? So it has higher effective nuclear charge, and what happens, its valence electron experience stronger force of attraction. Predict whether magnesium has higher or lower ionization energy than sodium. Magnesium has atomic number 12 and sodium has 11. So as magnesium has, like we are going to say, magnesium has higher ionization energy as its nuclear charge is greater than sodium. Explain why the second ionization energy of sodium is significantly higher than its first ionization energy. So second ionization energy of sodium is basically represented as, so you can see that second ionization energy is represented as this one because you are removing second electron from it. And what happens if you see the structure of sodium? Sodium is having 2 electrons in its first shell. It is having 8 electrons in its outermost shell and 1 electron in its last shell. So it has 8 electrons in its second shell and it has 1 electron in its outermost shell. So what happens when you are trying to remove second electron? Definitely you are trying to remove from the inner shell. So that is having more force of attraction towards the nucleus, and that is why we are going to see a larger jump in the ionization energy. So how we can write it as the second electron is removed from inner shell, which is more closer to nucleus and having greater force of attraction. So that is why there would be a higher jump in ionization energy when you are trying to remove the second electron. Write the electronic configuration of phosphorus. It belongs from period 3 and phosphorus is 1531. So let's write its electronic configuration: 1s2, 2s2, then we have 2p6, then we have 3s2, then we have 3p3. Now they are saying why argon has a lower chemical reactivity than phosphorus. Argon has 18 atomic number. It is 1s2, 2s2, 2p6, 3s2 and then 3p6. You can see p subshell of argon is completely filled. While p subshell of phosphorus is partially filled, making it more reactive. Because p subshell of phosphorus is like this. There are 3 orbitals for p subshell and they are partially filled, so it has the vacancy of 3 more electrons, so it makes it more reactive. Predict whether sodium or sulfur has a larger atomic radius. Sodium is having Na11 and they are basically in the same period. So sulfur is 16. What happens? There is increase in nuclear charge. You can see it has more protons. So it has increase in the nuclear charge. What it does? Because of increase in nuclear charge, the valence electron are pulled more towards nucleus, because of greater attraction of greater nuclear charge. The valence electron are pulled more towards nucleus and hence atomic radius decrease. Hence sulfur atomic radius decrease. So how can we write it here? We can write here that sodium has larger atomic radius. Sodium has larger atomic radius and because it has fewer protons than sulfur, because it has fewer protons than sulfur. Why transition metals? Explain why transition metals do not always follow the standard Aufbau principle. What is the reason? Because transition metals often lose s electron when they want to form an ion. So transition metals, what they tends to do, transition metal, they would lose s electron, s subshell electron first, then d electrons. Why? Because high energy d orbitals, what they tends to do, d orbitals, they stabilize. Now I can write this part here, that they stabilize either by partially filled or completely filled electronic configuration. So in this question they are saying a sample of element Y is analyzed in the laboratory. It has atomic number of 12 and 2 common isotopes which are 24 and Y25. So first let's write the electronic configuration of element Y. It is going to be, as its atomic number is 12, so it is going to be 1s2, 2s2, 2p6 and then we have 3s2. Now, by seeing the photoelectron spectrum, there are 3 peaks which are labeled as A, B, C. Identify the electron subshell that corresponds to each peak. You can see that it has 2 electrons, and its binding energy is maximum. So the shell which is closest to the nucleus, its binding energy is maximum. So that one would be 1s2. This one would be 2s2. And the one which is having 6 electron, it is going to be 2p6. So it is going to be 1s2, 2s2 and then 2p6. The sample also contains the isotope Y25. Define the term isotope. What are isotopes? These are atoms of an element having same atomic number but different atomic mass. You can see chlorine. Chlorine is Cl1735 and this chlorine is 1737. You can see they both are isotope and they have the same atomic number. Atomic number is same but mass number is different. Or you can even say the same number of proton but different number of neutrons. Explain how the mass spectrum of Y would reflect the presence of both isotope. So mass spectrum, if we represent like mass spectrum, then you know that in mass spectrum on x-axis we have mass to charge ratio and on y-axis we have percentage abundance. So if we want to represent like the mass to abundance ratio of these two isotopes, then definitely it is going to have two graphs like this. If this represent 24, then this represent 25. This is the way how the isotopes are represented on mass spectrum. And basically the mass spectrum show two peaks. They show two peaks. You can see they have two peaks there and two peaks for Y atoms at m by z is equal to 24 and 25 with relative abundance, that is on y-axis with relative abundance. The first three ionization energies of element Y are shown in table below. So you can see there are first three ionization energies and they are saying use this data to determine the number of valence electron in element Y. If you see first and second ionization energy, then it is almost getting doubled. But if you see second and third ionization energy, then it is increasing more than 4 times. Why is that? That means the outermost electron, the valence electron, there should be 2 valence electron. Why? 2 valence electron. Why? Because 2 valence electron, because there is large jump of ionization energy of second and third ionization energy, because definitely the outermost electron would be having 2 electrons, and when you are trying to withdraw electrons from the inner shell, there is a large difference of ionization energy. Okay, because when you are withdrawing the third electron, then the ionization energy would be quite large. The reason is that because of greater force of attraction, because of greater force of attraction of nucleus with the electrons that you are pulling more towards from the nucleus. Why third ionization energy of element Y is significantly higher than the first and second? Now let's write the details for it. Because what happens, removing a core electron, this is the core electron, they are saying this is the core electron which represent the third ionization energy, requires much high energy, and what are the reason? The first reason is due to less shielding. Definitely, you know, shielding electrons are those electrons that are present between nucleus and valence electron. Now here the valence electron becomes this. So the if nucleus is this one and this is the first shell, now you can see there are only 2 shielding electrons, and before there were 10 shielding electrons, and shielding electron basically pushing the valence electron outwards. That decreases the ionization energy. So now there are only 2 shielding electrons, and what happens because of that? Due to less shielding and closer attraction to nucleus, that is offered here. Element Z has an atomic number of 13. Which element Y or Z has a greater atomic radius? Y has the atomic number of 12. Okay, Y has the atomic number of 12. So we know that because it has greater nuclear charge means more force of attraction between nucleus and valence electrons. So because of greater nuclear charge, what happens? There will be decrease in atomic radius. As there will be more force of attraction of nucleus towards valence electron. Now we have to see this complete photoelectron spectrum of an element in its ground state is represented below. So first of all, we need to write the electronic configuration. So this one is having the highest binding energy, which means closest to nucleus. That means it is going to be 1s2. This peak represents 2s2, and this one represents 2p6, because they here the one line that represents 2 electrons, second line represents 4 electrons, third line represents 6 electrons. Then we have 3s2, then we have 3p6, it represents 6 electrons, then we have 4s2. So if we write the electronic configuration here, it is going to be 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. And what is the element there? 4 plus 6 is 10, 10, 12. 18, 20. So 20 is calcium. Calcium is having 20 atomic number. Now they want us to calculate the wavelength in meters of electromagnetic radiation needed to remove an electron from the valence shell of the atom of the element. Now, if you see this question, then what we need to do, we know about this two formulas for this one. E is equal to hv, where h is the Planck's constant whose value is 6.626 times 10 raised to power minus 34. And first we need to find the frequency. Okay, frequency is going to be E divided by H. E represents the energy required to remove the valence electron. So energy required to remove the valence electron is going to be this one, because valence electron is 4s2. E is 6.626 times 10 raised to power minus 34. H is going to be 0.980 times 10 raised to power minus 18. And that comes out to be how much? 1.479 times 10 raised to power minus 15. And after that we have the formula C is equal to V lambda. Lambda represents the wavelength. And here we want to find the wavelength. And wavelength is equal to C by V. C is the speed of light whose value is 3 into 10 raised to power 8. V represents the frequency and its value we have already calculated, 1.479 times 10 raised to power minus 15. And wavelength is in meter and its value comes out to be 2.03 times 10 raised to power minus 7. It is in meter. Thank you so much.